opposite over hypotenuse, which is y divided by 1. It's the y coordinate. So, can someone tell me what the sine of 45 degrees would be? Other than Chris? Yes, ma'am.
The square root of 2 over 2.
It's also the square root of 2 over 2. It is the y coordinate. So, the idea is that I'm having a hard time figuring out whether you guys, how comfortable you are with the values on this unit circle. Okay, but the big takeaway is you've already filled this out, or you've been shown it. Okay, these values come from these special right triangles, and the coordinates are related to the sine and cosine values of the various angles. Okay, so can I see this one for a second? So if I'm looking at this right here, okay, the big thing that we need to take away from this is if I ask you what the sine or cosine of any angle on this unit circle is, we should be able to know what its value is based on either the x or y coordinate. Okay, so just to make sure we understand this concept, it may be overly simple, but I don't know where we're at. If you could, using this unit circle, just jot down for me what is the sine of the following angle measure, just to make sure we're good. Okay, let me see that. All right. So I want you to find this. Just jot down what is the sine of all the values in the first quadrant from 0 to 90 degrees, based on what we know about the unit circle. Sorry, that's 30 degrees. So 0, 30, 45, 60, and 90. Go ahead and talk to each other if you need to, please. find the sine. That's why we're saying the sine.
And then the
I want to know the sine of the two coordinates. One down here.
We don't have any.
One right.
now, and it also,
So the sine of 0 degrees has to keep. Whereas the y coordinate is the sine of 0 is here. The sine of 30 can be whatever the y coordinate is.
that's tripping on it.
Why does it make sense? Because sine of here, 1/2 would be this length is the side. That's my opposite.
Yeah, me too.
My hypotenuse is 1. So 1/2 divided by 1 is 50. And that's the definition of close. Follow me? That's where it's going, 45. Y coordinate, but that's my opposite.
Había una loca junto a mí. I was like separating. And when the dude would call 5 minutes, she would just both like
Okay, so
and left it like separated.
we're getting there slowly. Okay, here's the big, just to kind of walk you through this. Now, I know this is a link that you guys have not made yet, and that's okay. Okay, so the idea is, teachers may have you think otherwise. But this unit circle is useless if you don't make the connection to how it matters with sine and cosine. Memorizing these numbers is a waste of your time. Okay? It is. Now, if you don't make the connection, I'm not saying, right? It's important. It's hugely important. You're not going to escape this for the rest of your high school math careers. Okay? It's unavoidable. Okay? But the key is the connection that it makes with sine and cosine. Okay? So the idea is this. At 0 degrees, the coordinates at this point are 1, 0. Okay? You've been dealing with coordinates since middle school, right? 1 is called the x-coordinate. 0 is called the y-coordinate. Okay? What we've done today is we've defined that y-coordinate to always be equal to the sine of the angle. So if I ask you, what is the sine of 0? I go to 0 degrees, I look at the coordinates, and I just ask which one of these is the y-coordinate. 1 or 0? 0 is. So what is the sine of 0 degrees? It's 0. Okay? What is the sine of 30 degrees? I don't write down the entire coordinate pair, right? The square root of 3 over 2 is the x-coordinate. The 1/2 is the y-coordinate. Okay? The sine is always the y-coordinate. So what's the sine of 30 degrees? 1/2, because that's the y-coordinate. Now, why is sine the y-coordinate? Well, it goes back to this idea of SOHCAHTOA, right? The idea that if I'm looking at this thing, opposite over hypotenuse, the opposite is the y-coordinate. So you're not saying sine is the y because some random teacher that you're going to see one time and that's that is saying so. Okay, it's because it's how it's always been, right? Right triangles. You've been dealing with this probably since geometry. Okay, so now that we know the sine is the y-coordinate, we can keep working through this, right? I want to know at 45 degrees what's the sine. All I need to know is what's the y-coordinate. It's square root of 2 over 2. Right? What's the sine of 60 degrees? Well, the x is 1/2. The y is root 3 over 2. So the sine of 60 is square root of 3 over 2. What's the sine of 90? It's 1. Okay? And we could keep going all the way around. But I'll not spend the time. Okay? But can you see how this is important? Or how that relationship is linked? Okay? So what we're getting to, wait, 16 minutes? When are we at here? 48?
Yeah.
Okay, thank you. what we're getting to, what's gonna happen, looking at these y coordinates, what's gonna happen as I continue into the second quadrant, okay, to the y coordinates? What's the sine of 120? It's the square root of 3 over 2, which we just got here, right? These values repeat, because it's the same triangle, just in different orientations on the unit circle, okay? So, right before your little 2-week ACT break, you guys, were talking about period, or like, what was it? Did you deal with a Ferris wheel problem or something?
Yeah.
Okay, can someone tell me a little bit about it? Just give me a little takeaway from it. Anyone remember? That was over 2 weeks ago?
Oh, I know the story.
3 weeks ago? So just in past? Okay. Oh, then we had spring break before that? Okay, so, here's the idea. Let me switch gears just a little bit. Actually, using the same mindset, now that we made this link between the y coordinates, if you could, I'm going to ask you to find the sine of just a few more angles. What would the sine of 180 and 270 and 360 be? Okay, so I'll leave this unit circle up here. So just find 3 more forms. Sine of 180 and 270 and 360. Based on what we just talked about with it being in the y coordinate. Okay. So, again, we're looking at that y coordinate, and the sine of 180 degrees is the y coordinate of this point, which is 0. Which makes sense because the height is 0, right? There is no opposite side at all. Okay, for 270, I'm down here at the bottom. The y coordinate is -1, and 360 isn't on this unit circle. It goes to 330. Where is 360? It's back at 0. Okay, so there's. We'll talk about what is it possible to have an angle that's bigger than 360? We know in real life it's possible to turn around more than one full time, right? So we'll talk about what that would look like with the unit circle in just a second. But I want to briefly, here's where we're going with this, okay? What we want to try to figure out is what the graph of y equals sine of theta would look like, okay, as a function. So functions have inputs and outputs, right? In this case, the sine of theta, the sine values are those y coordinates we just talked about, right? The inputs to this equation would be angle measures, right? And we want to look at what the graph of this would look like. Okay, so I want to see if I can show you something that might make sense of this. So here we have here's the unit circle. Okay,